Okay, so now let's look at the real chemistry. We went through some examples, and I think we've established now that there's no quick and dirty way to recognize these things. So the molecular equation tells us what's on the bench and what we're working with. But ionic equations and net ionic equations tell us what's really going on. So everything we've looked at so far was a molecular equation. We had the formulas for the compounds written down in the equation, and then we put them in there as aqueous or solids or gases or liquids. The ionic equation shows what actually exists in solution, kind of what's in my beaker. So when we think about this, if we have a strong electrolyte that is soluble, this means generally ionic compounds or strong acids. Maybe this will help breaking it down to give you kind of those rules you're looking for, Alex. If these things are in there and they have the AQ subscript, then we break them apart and we put them in ionic form, because that's really what's in my beaker. So if we have HCl aqueous, which is a strong acid, and we look in that beaker with our molecule seeing I, what we really see is hydrogen ions and chloride ions. So the ionic equation represents for us what's really in the beaker that I would see with my molecule seeing I. Insoluble strong electrolytes are written as compounds, as solid, because they're sitting at the bottom of the beaker. So if I have something like iron sulfide that's a solid, it doesn't dissolve, then I write iron sulfide, solid, and I leave that in the ionic equation. It does not break apart into its pieces. Weak electrolytes, things like water and acetic acid. Acetic acid is a weak acid. We write these as I have just written them. We write them in their molecular form because they are mostly in the molecular form. If I look in there with my molecule seeing I see the acetic acid molecule. I don't see acetate ions and hydrogen ions. Not very many. I see a few, maybe 1%. Then non-electrolytes are written as compounds. Things like methanol. Methanol is a non-electrolyte. This does not break apart, so I just write it as methanol. It still has the AQ subscript because it is in water. It's just not broken apart. So this means that you have to recognize strong electrolytes and weak electrolytes. You have to recognize solids from the solubility rules. And also the thing I didn't write down here is anything that's a gas, we also write in the molecular form. So if you have HCN gas, now it's a gas, it's come together, the ions have hooked up and they're bubbling out of solution. And you remember the goal of metathesis is to get ions out of solution, and we do that 3 ways. We do it by making a gas, making a weak electrolyte, or making a solid. So the ionic equation tells us what's really in the beaker. The net ionic equation is the one we're interested in. This shows the real chemistry. So any spectator ions, ions that are on both sides of the equation, get eliminated to see the real chemistry. Think about this. If you go to a hockey game, I like to go to hockey games. I like to watch hockey. It's fast, it's fun, right? I go there and I pay to sit there and watch the hockey game. I am a spectator. They do not allow me to go out on the ice and score goals. So me being there does not necessarily affect the outcome of the game at all. They're going to do what they're going to do regardless of my presence. However, the fact that I am there and willing to pay to be there allows them to pay the players, to pay the guys that are selling the hot dogs, and to heat the building, and to clean the ice, hire the Zamboni guy, right? You know the Zamboni guy. I want to ride on that. The what? A movie? No, I don't. Is it nasty? Is it a lot of swearing? Action? Is it any worse than Die Hard? I like the Die Hard movies. Action, there's a lot of swearing in that. No, I'm saying that I don't mind. I don't really like the swearing, but if there's a lot of action, I can tolerate a little swearing. Okay. Okay. Mostly I like the Dirty Harry movies. He's not really swearing. You know, I know they're old movies. Do you know the Dirty Harry movies? Yeah, I love that. When he's standing there saying, I know what you're thinking. I think that's great. And so, do you feel lucky? My favorite movie. All right. So, the spectator ions are removed. So, let's look at an example. Here we have sodium hydroxide reacting with hydrochloric acid to give us sodium chloride and water. That is our molecular equation. It's balanced. We have all the subscripts in there. Now, let's break this apart and say what's really in my beaker. Sodium hydroxide is soluble and it's a strong electrolyte, so it breaks apart. So what's really in my beaker is sodium ions and hydroxide ions. HCl is really hydrogen ions and chloride ions. Sodium chloride, same thing, sodium ions and chloride ions. Water stays hooked together because it's a weak electrolyte. So now I look at this and say, well, is there anything in that beaker that appears on both sides of the equation? And the answer is yes. Sodium appears on both sides. It's not doing any real chemistry. It just took hydroxide into the beaker. Chloride appears on both sides. It's not doing the chemistry. So what's left is hydroxide hooks up with hydrogen to make water. I used the analogy of going to the dance and trading partners at the dance. And I told you about this in the context of a dance class. But in high school, when they had the high school dances, people would go to the dance and then they would dance with other people and sometimes hook up and go home with somebody else, right? Well, that's what I heard. I never went there. But anyway, when I was in high school, I didn't go to the dances because you had to have a date. And I had difficulties in that area of my life in high school. I didn't have any dates. Nobody wanted to date the president of the Girls Rifle Club. I don't know why. And yes, there was a girls' rifle club and a boys' rifle club, and we had a rifle range in the basement of our high school. It was awesome. And the high school owned the firearms and provided the ammo, and we'd go down there and shoot 2 or 3 times a week. It was a really great way for get rid of your aggression on the range, yes.
Nobody ever came and bothered your school, did they?
No, but you have to remember it was a different time. I grew up in a very different world than we live in now. So, well, we won't get into that, right? We're not going to discuss the merits of that, especially in light of the recent things that have happened in the United States. We're not going to discuss that, all right? So, you have to have somebody taking you to the dance. We need something that got hydroxide and hydrogen in the beaker. And then they can hook up, and this is the real chemistry. So let's look at another one. This 3 is supposed to be subscripted. Fix it on your copy. So we have silver nitrate plus lithium bromide. They make silver bromide solid and lithium nitrate aqueous. So when I look at this, I say, okay, my silver nitrate is a strong electrolyte and it dissolves, so I break it into pieces. I have a silver ion, which is aqueous, plus a nitrate, which is aqueous, lithium, aqueous, plus bromide is aqueous. Now, silver bromide stays as a solid because it hooked up and it's sitting on the bottom of the beaker, plus lithium ions, plus nitrate ions. Now, I go back and put in all my subscripts. So, lithium ions are floating around in the beaker. They're aqueous. So is the nitrate. Now we look at our net ionic equation. So the net ionic equation, we see what's left. I have lithium on both sides. I have nitrate on both sides. So now I have silver ions plus bromide ions make silver bromide solid. So the net ionic equation shows the real chemistry. In order to have real chemistry, you have to have a solid, a gas, or a weak electrolyte forming. If you don't get one of those things, then everything will cancel. And when everything cancels and we don't have any real chemistry, what we write for the net ionic is NR, no reaction. So that is not this example. But if you have no chemistry, if you don't make a gas, a liquid, weak electrolyte, or a solid, you have no chemistry. Okay, now we're going to go ahead and do the ones on the next page.